Welcome to this video on geometric sequences. By the end of this video, you should be able to write a geometric sequence in the explicit form. All right, let's take a look at our notes. So a geometric sequence is a sequence of numbers in which a common ratio between consecutive terms is constant. And what a constant ratio is you will multiply by the same value each time. And so the common ratio will be noted by R equals, and it's whatever you're multiplying by each time. If you were to graph a geometric sequence, it would resemble an exponential function. So it's related to what we've been talking about. So can we tell whether or not a sequence is geometric? So remember, we're looking for a common multiplier between all the terms. So when we look 4 to 8, we got to think multiplication here because we're talking about geometric. That would be times 2. 8 to 16 would also be times 2, 16 to 32. So I'm just checking all the terms. They're all multiplied by the same number, 2, to get to the next term. So yes, this is geometric, and your common ratio is a positive 2. Let's try it again. 2 to 6, using multiplication, would be times 3. 6 times 3 is 18. 18 times 3 is 72, and 72 times 3 is 360. So yes, this is a geometric sequence, and your common ratio is a positive 3. All right, let's take a look at number 3. One thing that you should notice right off the bat is that our signs are alternating, negative, positive, negative, positive, negative. So what we might be looking at here is a negative multiplier. So let's see, if we want to get to a negative 3 to a positive 6, if we multiplied it by a negative 2, that would work. Negative 3 times negative 2 is positive 6. Let's see if the pattern continues. So positive 6 times negative 2 is negative 12. Negative 12 times negative 2 is positive 24. So we're seeing the pattern. When you see the alternating signs like that, you're talking, if it's going to be a sequence, you're going to have a common ratio that's a negative number. So yes, this is a geometric sequence with a common ratio of negative 2. Well, now let's look at 4. It presents a new situation to us. Up until now, our numbers kept getting bigger. So when I look at number 4, I notice I'm actually dividing by 2 each time. Okay, so when you're dividing, when we talk about the formula in just a minute, it doesn't allow for dividing. So we can write dividing by 2 as a fraction, dividing by 2. Well, what goes in the top of that fraction is just a 1 to hold its spot. So you're really multiplying by 1/2 each time. So yes, this is a geometric sequence, and your common ratio will be 1/2. Okay, let's try it again. So these are going smaller, so we have to think about multiplying by a fraction here. So 80 to 40 would be a divide by 2, but 40 to 30 is not a divide by 2. So this is not a geometric sequence. It doesn't work because it's not the same common ratio every single time. And finally, number 6. So see how we have all negative signs this time? That means we're going to be multiplying by a positive number because the signs aren't changing if this is going to work. So negative 8 times 4 is negative 32. Negative 32 times 4 is negative 28. So it looks like, yes, this is a geometric sequence, and our common ratio is a positive 4. Now we can take that and we can continue a sequence that's given to us. So we got to find the common ratio, and then we can continue the sequence from there. So we're talking about geometric sequences here, so we're talking multiplying. So 3 times what is 12? That would be 4. 12 times 4 is 48. So what we want to do is take our calculator. 48 times 4 is 192. 192 times 4 is 768. And 768 times 4 is 3,000. 72. So we just found the next three terms of that sequence by following. We can do that for as long as we like. So what I want you to do is I want you to pause the video and I want you to try these next two, continuing the pattern, and pay attention. Look at this, negative, positive, negative. So think about what we said up just above, what we said when the signs alternate like that, and unpause the video when you're done. All right, so, and number 8, our common ratio is -2. So when I kept multiplying by -2, I got positive 48, negative 96, positive 192. And for number 9, our common ratio was 1/3. So you're really dividing by 3 each time. So you'll get 15, 5, and then the last one we can just write as 5/3. You could have written it as the decimal if you wanted to, but usually we keep them as fractions. All right, so instead of taking your calculator and working this out to find all the terms, so this is in our sequence, this would be the first term, this is the second term, this is the third term, and then we found terms 4, 5, and 6. We could keep doing that same pattern, multiplying by -2 for as long as we want. But what if I asked for the 50th term? Do you really want to have to do that out to 50? So there's a shortcut to make this happen. And so here's our formula. It's a sub n equals a sub 1 times r raised to the n minus 1. So to find any number, which is the nth term, so a sub n means any term. It's kind of like saying y equals to find any y. So to find any term, you will take the first term in this sequence. This is your common ratio. And then you'll multiply it to n minus 1, and n is what term are you looking for? Okay, so I want to look at this formula a little bit closer because it's actually like our formula that we did for our exponential functions. Because remember when I said if you graph this, it will resemble an exponential function. We would say a times b to the x. Okay, a times b to the x. So this is directly related to our exponential functions, but we only use this when they use the term sequence. Okay, all right, so let's kind of look at this. So if I look at these sets, we're going to write a formula and then find a specific term from it. Thinking about multiplication, what times 6 gives us 24? It looks like 4, and then you just double check. Is 24 times 4 96? Yes. Is 96 times 4 384? Yes. Okay, so that means your common ratio is 4. Your first term, that's 6. Your second term is 24. Your third term is 96. So that kind of gives you the idea. So we're going to say to find any term in this sequence, we're going to take the first term and multiply it by 4, and its exponent will be whatever term we want minus 1. Okay, so if we want to find the 8th term, what you'll do is you'll plug in 8 right there and we'll calculate it. So we have the first term times the common ratio raised to the 8 minus 1 gives us 98,304. So 98,304. We could have kept following this pattern of multiplying by 4 until we got out to the 8th term, but we can just plug it into the formula and jump right to it. So let's try it again. Let's see if we can find the common ratio on number 11 here. 1 to 6 using multiplication would be times 6. 6 to 36 is also times 6. So our pattern's holding up. So our R is 6, our common ratio. Our first term is 1. So to find any term in this sequence, we're going to take the first term times the common ratio raised to n minus 1. That's to find any term. We specifically want the 10th term, so you're going to go and place 10 where the n is. So we have 1 times 6 raised to the 10 minus 1. Ooh, that's a really big number. That gives us 10,077,696. So we could have just kept multiplying this by 6 by 6 by 6 each time, but we can jump to it, and that's the whole point of the geometric sequence, so we can find our term immediately. All right, so let's try number 12. Notice how the signs alternate, positive, negative, positive, negative. That means our common ratio is going to be a negative number. Okay, so we're going to look. What times 7 gives us negative 14? Well, that'd be a negative 2. Check to see if the pattern holds. Negative 2, negative 2. It follows for all of those, so our common ratio is negative 2. 7 is the first term, so to find any term in this sequence, we're going to take 7 times negative 2 raised to the n minus 1. We want the 12th term, so I want you to plug 12 in right there. So we have 7 times negative 2 raised to the 12 minus 1, or 11. And we got negative 14,336. All right, pause the video and try number 13 and then come back when you're done. All right, so I made this one a little tricky on you. This one was, we were dividing by 3 each time, and remember our formula doesn't allow for dividing, it only allows for multiplication to the common ratio. So to show dividing by 3, we write it as 1/3. And then you end up with this decimal. And it's okay to leave it as the decimal. We'll talk about different ways that we can check that if this were a test situation. So on number 14, we have all negative numbers. So what we're going to be working with is a positive number, but they're getting smaller. So that really means we have to be dividing. So 8 divided by 4 is negative 2. Negative 2 divided by 4 is negative 1/2. So we're dividing by 4. So we would write divided by 4 and just put the 1 as a placeholder in the top. Okay, so our first term, to find any term in this sequence, our first term is negative 8. And then our common ratio is 1/4 raised to the n minus 1. So that's our model for any term in this sequence. So let's find the 5th term. So negative 8, 1 divided by 4, raised to the, we were going to plug a 5 in here for n. 5 minus 1 is 4, so I'll just put a 4 there. And I got a little decimal. That's okay, leave it, and we'll talk about that. 0.03125. Okay, and our last one. There's a little typo, just stick a negative sign in front of the 49 and that will fix the typo. So we have all negative terms, so what we're multiplying by is a positive term. So to get through from 1 to 7 through multiplication, you'd have to multiply by 7. Negative 7 times 7 is negative 49. So our value, our common ratio, is 7. So to find any term in this sequence, our first term is negative 1. Our common ratio is 7 raised to the n minus 1. And we want the 12th term, so you're going to plug 12 in for n. So negative 1 times 7 raised to the 12 minus 1 is 11. So we have negative 19,977,326,743. So when we look at this as a number, negative 1,977,326, negative 1,977,326,743. Really big number, okay? So to write the equation of a geometric sequence is pretty straightforward. You just need to identify the first term and what it's multiplying to for us to be able to create the sequence. Now, let's flip this over and I'm going to challenge you just a little bit. Okay, on the back here, I'm telling you to find what is the first term given that the sixth term is 64 and our common ratio is 2. So let me show you what I'm really saying here. I'm going to write this out. We're looking for the first term. We know that the sixth term is 64. So I'm just going to count my way there. So the sixth term is 64. And the common ratio was 2, meaning when I was going this way, I was multiplying by 2. So if I'm multiplying by 2 going to the left, that means I do the opposite going to the right, which will be divide by 2, which will be really is multiplying by 1/2. So we're just going to follow the pattern. If we take 64 and multiply it by half, we get 32. If we multiply 32 by half, we get 16. 16 times 1/2 is 8. 8 times 1/2 is 4. And 4 times 1/2 is 2. So if I put an A right there, A sub 1, the first term, is 2. A sub 1 equals 2. All right, let's try that again. So we want to find the first term given that the fourth term is 8 and my common ratio is negative 2. So I'm going to draw this out to give me some room. So I'm looking for the first term. There's the second term, third term, and the fourth term is what we know. It is 8. When we're going this way, we're multiplying by negative 2. That means when we're going this way, we would be dividing by negative 2 or multiplying by negative 1/2. So we have 8 times negative 1/2 will give us negative 4. Negative 4 times negative 1/2 will give us a positive 2. Positive 2 times negative 1/2 will give us a negative 1. That takes us to where we want. So the first term of the sequence will be negative 1. Okay, so pause the video and try this one. This one might be a little trickier. I'm giving you the 8th term, and we're multiplying by 3 going to the right. That means you're going to be dividing by 3 going to the left. So go ahead and give it a try and come back when you're done. All right, so I drew this out, and in the 8th spot I put 4,374, and then I just kept dividing by 3 and moved my way back until I got to the first term, which is what we were looking for. So the first term was 2. Okay, so for our last one, it's asked a little bit different. We want to find what the n is. The n is the position. What position is 9 if your common ratio is 3 and your first term is 1? So let's just draw out what we know. We know that the first term is 1 and our common ratio is 3. So going this way, we're going to multiply by 3. I want to know what position is 9. Okay, so 1 times 3 is 3. 3 times 3 is, well, there's our 9 right there. We don't have to go any further. We got to what it asked for. They want to know what position, what n is at. So this is the first term. That makes this the second term. The third term. So 9 is in the third position. All right, hopefully this was helpful. Let me know if you have any questions, and I'll see you in class.